So the next question here is, so determine z parameters for a given network with ZA equals to 2 J ohms and ZB equals to 2 ohms. So here the network is one dash, two dash, and this one is ZB, ZA, and ZB. So this is your network. Okay. So which was asked in GATE 2004. Okay. So now listen. So already we have one formula, right, for this type of configuration. Okay. For this type of configuration, so this one is ZA and this one is ZB and ZB and this one also ZA. When ZA equals ZD and when ZB equals to ZC, okay, that means symmetrical lattice network. Okay, for this type of configuration we have one formula, that is Z equals to ZB plus ZA by 2 and ZB minus ZA by 2 and ZB minus ZA by 2 and ZB plus ZA by 2. Okay, but when you compare this network to this network, okay, so here these two elemental values are replacing, right? So when compared to this network, those elemental value can be replaced there, right? Just you can interchange the parameter values also. Here we have ZA plus ZB by 2 and here ZA minus ZB by 2, here ZA minus ZB by 2 and here also ZA plus ZB by 2. So in that way, if you calculate Z parameters, so now Z equals to this element value plus this element value by 2, right? So for that case, ZA plus ZB by 2, okay, that equals what? 2J plus 2 by 2, okay. And next one, there ZB minus, and that means what? This one minus this one by 2, okay. Here also same thing, ZA minus ZB, this element minus this element by 2. So this ZA value equals what? 2J, okay. Now 2J minus 2 by 2, and this is the given network is symmetrical network. Symmetrical network means what? Condition equals what? Z11 equals Z22 and Z12 equals what? Z21. Here we have Z11 value, okay. So Z11 equals what? Z22. So here also we will get 2J plus 2 by 2 and Z12, this is Z12, okay. Z12 equals what? Z21. So same thing you can replace here. So 2J minus 2 by 2. So finally what you will get? So now here 1 plus J and here minus 1 plus J and minus 1 plus J and this one is 1 plus J. This is your Z parameters for a given symmetrical lattice network. So which was asked in GATE 2004. And one more way is, so same thing you can calculate in different way, right? So now this you can observe this network, okay. So here I am indicating variables V1 and I1, and here V2, sorry, plus minus V2 and I2, right? So now I am taking 4 terminals. This is 1 and this one is 2 and this one is 3 and this one is 4th terminal, right? This one is 4th terminal, right? 4 terminals we have, right? Now the first first element z11. Okay, if you want to find out this z11, so we need to make I2 equals 0. That means port 2 can be open circuit, right? So now here z11 equals to v1 by I1 only when I2 equals 0. For example, if you assume this I2 equals to 0, okay, this I2 equals to 0, okay, that means this is completely open circuit, right? Okay, now so here the current is divided into two parts at terminal 1, right? So for example, if you assume here some current we have, that is I1. This I1 current can be passing through this ZB element, at the same time ZA element, right? Up to this we have current I1. From this point onwards, current can be divided into two parts. Okay, so one is this way, another one is this way, right? Once you observe, if the current is divided into certain amount of two branches, so certain amount can be passing through this ZB resistance. Once the current is reaching towards this third terminal, okay. Now what happened? So here we have certain amount of current, okay. So here completely open circuit, right? This is open circuit, so that here the contribution of this third terminal current equals to 0. Open circuit means open circuit, so that I2 equals 0. Here the contribution towards this third terminal equals to 0 amount of current, right? Here the coming current 0. Here also we have certain amount of current. This complete amount of current can be flowing through this ZA resistance, right? So because of this open circuit, this current cannot be moved towards this V2 side, right? So whatever the current we have in this branch, same amount of current can be passing through this ZA branch, right? So because of this open circuit, there is no current flowing through towards this side, right? So complete current can be passing through this terminal. That means what? This is completely, we can consider as one branch. This complete branch having total impedance equals to this ZA plus ZB. If you assume this one as one complete branch, okay. So this branch having two resistive elements, one is ZB and the one is ZA, so that the total branch impedance equals what? ZA plus ZB. Okay. For this ZA plus ZB, we have certain amount of current, right? In the same way, you can observe this path also, right? So here we have ZA, and which is passing up to fourth terminal. At this fourth terminal, we have open circuit. The current is the current towards this path 0. Why? Because this is open circuit. Open circuit current equals 0. So that the current in this branch equals to 0. The entire current can be passing through this ZB resistance. That means the entire current passing from this to this only, right? So if you consider this complete path as one branch, this complete branch resistance equals what? This is ZA plus ZB. That means this entire branch having two elemental values, that is ZA ZB. If you consider total resistance, that is ZA plus ZB. And this path also having ZA plus B, and this path also having ZA plus ZB. That means what? The current can be divided for these two terminals in an equal manner, right? Here we have I1 means what? Entire this branch having how much amount of current? I1 by 2, and this branch also having I1 by 2 amount of current. Now, so if you observe, so for these two branches, the voltage drop equals to how much? V1, right? That means what? Here the V1 equals to the current into this particular branch resistance, right? So now what you will get here? So first one, otherwise okay, listen. here this I1 current can be divided into two equal parts, I1 by 2 and I1 by 2. So now here I1 equals to I1 by 2 plus I1 by 2. So once you observe this I1 by 2, that means for this branch of current, okay, this I1 by 2 equals to voltage drop across this entire branch by total impedance. Now you can write here voltage drop across that complete branch equals to what? V1. And now complete this current value. I am writing here for complete this current. Okay, here this branch current equals how much? I1 by 2. This I1 by 2 equals to voltage drop across this branch by total impedance, right? So that is ZA plus ZB. And similar way I am writing for this current equation. So I1 by 2 is a complete amount of current. Otherwise you can treat as this is I1 dash. Okay, that is also no problem. For this I1 dash of current, I can write the expression voltage drop across this particular branch by total impedance, ZA plus ZB. Now what happened? This I1 equals to 2 times of V1 by ZA plus ZB. But we have V1 by I1. Okay. Now Z11 equals to V1 by I1 only when I2 equals 0, which is equals to V1 by I1 equals what? ZA plus ZB by 2. Here the ZA equals what? 2J plus 2 by 2. Here we will get 1 plus J. So given network is what? Is ZA ZA and ZB ZB. So that's symmetrical network. Okay, symmetrical network. For symmetrical network, what? Z11 equals what? Z2. So here this is Z11 as well as Z2. This is your Z11 parameter. This is also one way, okay, to evaluate the Z parameters. And the second one is Z12. Okay, and now here Z12 equals what? V1 by I2. Sorry. Otherwise, so this you observe this one. Okay, this is voltage drop across third and fourth terminal. Okay, that is V2. Okay, so just I want to evaluate voltage drop at this particular node, and same way voltage drop at this particular node. Okay, just you ignore this voltage. Okay, so here we have some V2 voltage, just you can keep aside. Okay, so here we have some node voltage, that is V3. Just I can denote as V3 for this third terminal, and the same way here also I can represent with V4. Okay, for example, okay, this is V4 voltage. That means at terminal 4 we have some voltage drop V4. We can assume as V4, right? Clear. Now, so this is V3. Okay, this terminal voltage V3. So here I2 equals to 0. Okay. Now here some voltage drop V3. Okay, that V3 means some voltage source. Okay, so voltage source means how it is look like, plus minus, and this is connected to this terminal, right? And here we have some ground. And similar here also V4 means what? We have some voltage source like this. Okay, this is ground, right? So this one is ground and this one also ground. So you can combine these two. Okay. Now if you apply the loop equation for this circuit by KVL, okay, by KVL, so what we get from here onwards, minus 2 plus, so that minus V2, and here plus 2 minus V3. Okay, that means plus V3, and here again minus 2 plus. Okay, then what happened? Minus V4 equals to 0. Otherwise you can start from here also. minus 2 plus V4 and minus 2 plus minus V2 and plus 2 minus, in that way also no problem. Otherwise you can start with V4, okay, minus V4 minus V2 plus V3 equals 0, okay. But I want to evaluate this V2 value, okay. Now what you will get? V2 equals to V3 minus V4, okay. So if you want to calculate V2 voltage, okay, then you can find out V3 as well as V4, then you will get V2 voltage, okay. Just I am focusing on this port 2 voltage, okay. Now, okay, so observe here, just V3 voltage, that means this V3 voltage, this is terminal 3 voltage, okay. So here we have some voltage drop, that is V1. At this terminal 1 we have V1 voltage drop, okay, and this V1 is connected to plus and minus terminal, so that we can consider this minus terminal as ground, that means reference node. So here I am connecting with some ground node, okay, 0 volts, right, okay. Here this terminal is connected to V1, here we have some voltage drop, so here V3. So if you want to calculate voltage drop across this branch, then you will take this difference between these two terminal voltage, that means V1 minus V3 will give the drop across this particular JB value, okay. In the same way, if you want to calculate this branch voltage, okay, you need to take difference between these two node voltage, then you will get the voltage drop across this particular branch, right. Just you can observe, at this end we have 0 volts, at this point we have V3 voltage, difference between these two node voltages is nothing but V3 minus 0, that is V3. So the V3 voltage drop appeared across this entire branch, okay. And in the same way, if you observe this one, so here V4 voltage drop is there at this node, and at the end of this branch we have 0 volts, okay. So this V4 minus 0 volts, so across this branch voltage equals what? V4 minus 0, otherwise V4. Once you observe this branch also, here we have V4 voltage and here we have V1 voltage. Difference between this V4 minus V1, otherwise V1 minus V4 appeared across this entire branch, right. So now you can observe this one, okay. So you want to calculate this V3 value, okay. So from this branch, okay, so the branch voltage is nothing but what? V3, which is appeared across this entire branch, not this branch, okay. In this branch, if you assume, so for this branch the voltage is nothing but what? This V3 minus V1. But for this branch, okay, so the branch voltage is nothing but what? V3 minus 0, so that we can take only V3, right. So I will take only this branch, okay. In this branch we need to evaluate current value, okay. If you get the current value, this current into this impedance equals to what? That particular voltage drop, which is equals to V3, right. So when I2 equals 0, okay, the current in this entire branch equals to how much? I1 by 2. That means what? In this branch also the current equals to same, I1 by 2. So now you will get V2 equals to I1 by 2 into that particular resistance value ZA. And in the same way, if you observe V4 voltage, so you want to calculate V4 voltage. V4 means for this branch the voltage drop across this branch equals to V4 minus V1, but for this branch voltage drop equals what? V4 minus 0, so that this entire branch voltage equals what? V4. So if you want to calculate this V4, the current into this particular resistance value will give the V4. So how much amount of current is passing through this particular JB value? So you have to calculate that current. If you get that current, then you will get the V4 voltage. So in this branch, this complete branch having I1 by 2 amount of current. So for this branch also having same amount of current I1 by 2. That I1 by 2 into ZB value will give the V4 old. So that equals to I1 by 2, okay, into ZB. Okay. Now V2 equals to I1 by 2 into ZA minus ZB. So now V2 by I1 equals to ZA minus ZB by 2. So here V2 by I1 is nothing but what? Z21, right? Only when I2 equals to 0. Okay, this is Z21. So the given network is symmetrical lattice network. So if Z21 equals to ZA minus ZB by 2 means obviously Z12 also same thing, right? So here ZA value equals how much? Something 2J, ZB equals 2, so that what do you mean here? Minus 1 plus J. So in this way also you can calculate this network. You can calculate the Z parameters for a given network. Okay, this is lattice network, K 2004 problem.